Hi, and welcome. The choice of motors plays an important role in the overall success of the build. Let's find out how to select the ideal motors for your quadcopter setup. But first, let's figure out what type of motors are used in radio control hobby. Quadcopters use motors of the brushless variety. When taking care of these motors, they're amazingly reliable. They produce minimum friction and can produce a lot of power in a small package, making them ideal for radio control hobby. The motors are made by having a cylindrical shell with magnets that rotates around a core of tightly coiled wire, and the propeller is basically mounted onto the shell. So it's the entire top part of the motor that spins, compared to traditional motors where only the motor shaft is seen rotating. A lot of complicated mathematical calculations are involved when designing these motors, and thankfully there isn't much you need to know in detail about the workings of these motors when buying them for your quadcopter. Let's talk about what to look out for when choosing a motor. First thing to look into is the kV rating of the motor. The kV notation stands for the number of revolutions our motor turns when 1 volt is applied to it. This number is the most important when selecting a motor. The kV number of the motor will drastically affect the flight behavior of your quadcopter. Depending on which type of quadcopter you build, you select the motors accordingly. Different size frame will use different types of motors. For bigger and heavier quadcopters, such as those carrying video equipment for example, you need a lot of power to allow the quadcopter to fly properly. This is where motors with low kV rating are very useful. These motors will produce more power without using excessive current, and they're capable of driving bigger, more efficient propeller, but will have a slower spin rate. Generally, the bigger the propeller, the more efficient it gets. For fast, agile, racer class quadcopters, it is more useful to choose motors with high kV rating. That means that these motors will have a very high spin rate that will make use of smaller, less efficient propellers and allow you to build a quadcopter that has high maneuverability. Now, what exactly is the kV rating and why does it matter? Think of the kV rating of your motors as the ideal spin rate. The motor will always do their best to get as close as possible to the rated kV figure. So imagine having a high kV rated motor with a small propeller and fast spin, which is ideal for small, agile quadcopters. This setup would work well. However, now try imagining keeping the same high kV rated motor that doesn't have a lot of power but attaching a lot bigger propeller to it. The motor will try its best to reach the ideal spin rate, but will struggle while drawing a lot more current and will eventually burn out. The same will be true for a low kV rated motor with low spin, which can produce a lot of power to drive bigger propellers, but instead has a small propeller attached to it. The motor will spin very close to its ideal rate, and most of the power will be wasted and not a lot of thrust will be produced. So the question is, which motor is the best for me? To generalize, bigger motors capable of producing a lot of power and torque will have a low kV rating and will be matched up with bigger propellers, which will be ideal for bigger sized quadcopters. This will produce more lifting power, but the quadcopter itself will be less agile, which is perfect for aerial photography where being as stable as possible is the end goal. On the other hand, smaller motors that will produce less power and have less torque will be matched up with smaller propellers and usually have high kV rating, which will be ideal for smaller racer class quadcopters. This will give the quadcopter more immediate speed, making it really agile and maneuverable. This is perfect for when you are building towards a quadcopter capable of aerial acrobatics. Another thing to consider, of course, is the choice of frame. The size of the frame will also influence the size of the motors you can mount onto it, which in turn will influence the choice of propellers. We will discuss choosing propellers in another lecture. The variety of the motors that are available in the market is quite extensive. So here is an example of the motors that was chosen to build a quadcopter specifically for this course. The aim of the build is to have a highly agile and fast quadcopter. The motor chosen is one with high kV rating and can make use of smaller propellers really effectively. Let's analyze what the specifications tell us. First number, 1806 in the name, means different things depending on the manufacturer. Sometimes it describes the diameter and the length of the motor's internals, and sometimes simply a model number. The main number you need to focus on is the kV number. In this case, the motor is rated at 2300 kV. When buying the motor, there will be other specifications listed as well. Things such as which type of battery the motor can support and the max current it draws. In the instance of the chosen motor, it supports a battery with maximum of 3S configuration. What that means will be explained later. Another notable figure is the maximum current draw, which in this case is 7.6 amps. This figure is very important for when you want to pair the motor up with the appropriate electronic speed controller and battery. So let's talk about how to purchase your motors. Several different brand names, several different specifications, so it can get a bit overwhelming. So the first step is to decide which type of quadcopter you would like to build. A larger one with the aim to record the most stable video, or perhaps one that you can use to do aerial acrobatics with. Second step is to choose a frame, which is discussed in a previous lecture. Third step is to check any recommended parts that might be listed alongside the frame, but that depends on the place you're buying from. Once you find the motor that you find that is a perfect match, read the reviews. Again, generally speaking, high kV motor for fast and agile quadcopters, and low kV motors for big and stable quadcopters. Make sure you understand the specifications. Keep an eye on three main important things: the kV rating, the type of battery it supports, and the max current draw in amps. The type of battery and the max current draw will help you select which type of electronic speed control to buy, and also which type of battery to buy. Fantastic! This should give you enough information to help you on the way to making an educated choice towards buying the motors for your quadcopter. Now let's move on to the next lecture, where you will see the actual motors being attached to the quadcopter frame. And as always, thanks for watching and see you in the next lecture.